Hi friends, welcome to Advaya Labs. Advaya Labs is all about having fun using science and spreading the beauty of science. And as promised, here is our first science fun video. Our topic today is micromotives versus macro behavior. And this is going to involve science and also people and society. But mind you, this is not some sort of propaganda or sociology course. This is pure science, and to give you a heads up, this involves the work of a Nobel Prize winning economist. So this is about science. So let me go to the next slide. Alright, here is our next slide. So here we have a map of Chicago. This is a color-coded map, and this map shows racial segregation in the city of Chicago. And towards your right is the legend. The red is white people, blue is black people, green is Asian people, and orange is Hispanic people. So what does this map show? In this city, this blue region is populated by African Americans. All the suburbs is all white people, and here you have pockets of Hispanic people and small pockets of Asians, green, color coded by green. So now you get a sense of what I'm trying to convey. This map shows racial segregation in this city of Chicago, and you might be tempted to say, oh my god, there is so much racism in Chicago. Hold on, this is a science video. Don't be tempted to make judgments and pass judgments. Premature conclusions are always dangerous. So before that, I also want to show you a couple of more maps of American cities. So just a minute. Here we have maps of LA and New York City. I went to school in LA. I love LA. Of course, I now live in Portland, but that's a different story. So look at the map of LA. You can see here the suburbs are all white people. This region, I think it's close to downtown, it is African Americans. Here you see a lot of Hispanic people, a lot of Asians. My uncle used to live somewhere over here in that region in Diamond Bar, and I used to see a lot of Asians when I was there in LA. And the same the case with New York. See a lot of African Americans in this region, white people in the suburbs in here, and all the suburbs here. And green is Asian people in that region. You get a sense of idea. You get a sense of what I'm trying to convey. You see a lot of geographical racial segregation in these cities. The macro behavior is geographical segregation, and we all might be tempted to say the cause for this macro behavior is the micro motives of individuals. Each and every individual is racist, so therefore the macro behavior of the city is racial segregation, geographical segregation. And we might be tempted to conclude that, but is that conclusion correct? So to focus on this point, let me go to the next slide. Alright, so what's going on here? Are people profoundly racist? Is the macro behavior, which is geographical segregation along the racial lines, is it because of the micro motives of the individuals, and the micro motive being racism, the micro motive being people wanting to live around people of their same kind? Is that the micro motive which is causing the macro behavior? Well, some might be tempted to say that, but even the opposite could be true. Maybe there is no relation whatsoever between the macro behavior and the micro motives. But how do we prove this? And now we are coming back into the realm of science. We are focusing on a phenomena which we observe in society. We are not making any judgments, no moral judgments, but we want to come up with a model, a scientific model that can replicate what is happening here. And if that model shows that micro motives need not necessarily lead to the macro behavior which we observe, then we have proved our hypothesis, right? And how do we go about creating such a model? People are complex creatures. People are so complex. Racism is such a complex issue. You need to model human mind, you need to model, perceptions, human relationships, a lot of other things. But imagine, think about this. I took a course on model thinking in Coursera, and I really had so much fun in that course. And I want to share the fun I had in that course with you guys. The thing is, you don't really have to come up with complicated models. With simple models, you can prove beautiful things, and that is what we will see in the next slide. And fortunately for us, we don't have to reinvent the wheel. If on the left you're seeing Dr. Thomas Schelling. He is the winner of 2005 Nobel Prize in Economics for his work in game theory, and he was an economist, and he did research on many areas, and his research on racial segregation was groundbreaking. And with simple models, with some beautiful simple models using just paper and pencil, nothing complicated, simple models, he showed that micro motives are not necessarily related or correlated with macro behavior. And there is something fantastic about modeling. There is a famous saying, and this is not Schelling's saying, but by a different person: all models are wrong, but some are more useful. All models, whatever models we come up with in science, they may not necessarily represent reality. They could be in that sense incomplete or wrong, but a lot of models are really useful. We could use them to make predictions, and they're really, really, really useful. So it is very important that we come up with a nice model. It doesn't really have to be completely true, but if it is useful for us in making some good conclusions, then it's a fantastic model. So how do we go about formulating such a model? Fortunately, Schelling did it using paper and pencil. We don't have to use that. His model is so simple that it could be done on paper and pencil, but we'll use a computer. Thankfully, we have computers to make our job easier. So give me a minute. So here we have NetLogo. NetLogo is an agent-based simulation and modeling language, and this has a library of models, and you can do a lot of fantastic things using NetLogo. And let me go open up the model we want to discuss now. See, in the models library, we have a whole bunch of models based on art, biology, chemistry, physics, computer science, earth sciences, games, mathematics, networks, social sciences, system dynamics. And today in social sciences, we'll discuss about the segregation model. And this is really fantastic. When I first learned about this in the model thinking course, I was blown away. This was fantastic. So the way we go about with our model is like this. Chicago is complicated as a big three-dimensional world, and we have people. We don't have to model people with all their brains and their thoughts and process and everything. All we will come up with a very simple abstract model. Imagine we have a two-dimensional world, which is a black box as you see here. In this two-dimensional world, we have a grid, and because there is a grid, it can be divided into a bunch of cells, and each cell can be populated with a person, and that person can be of either a red kind or the green kind. Here the red represents a person of a certain kind. It need not be just race. It could be religion, it could be education or whatever. People of kind 1 are represented by the red color, people of kind 2 are represented by the green color. So we'll choose at least say 1500 such people, and we'll call them agents, because agent is a name for for any person or entity which we would like to model. And traditionally in agent-based modeling languages, the term somehow agent caught on, but we'll use that word, the terminology. So we have a bunch of red and green agents in a two-dimensional world. So let's say in this case we choose about 1500 such agents, and the agents, we will choose the agents in such a way that their micro motives are very simple. let me just illustrate what I'm saying by just setting this up. When I do a setup, see, now you see a bunch of red and green agents. These agents are randomly created. Random in the sense that each cell, each position can either be empty, which is the black here, or it could be a green agent or a red agent, right? And now you can see what I'm talking about. And I started with about 1500 such agents. There is enough empty spaces here in this 2D world. And the way I set up is each agent has certain micro motives, and he has a simple micro motive. He'll stay in this cell in whatever place he was created if at least, say, in this case, 30% of his neighbors are of the same kind. If there's a red guy here, say here, this red guy, he'll stay in the same place if 30% of his neighbors are red guys, or if it's less than that, he'll just move away to some other place. Say there's a black region which is an empty space, he'll move to the black region. And if you so in each step of the simulation, each and every agent will first evaluate his micro motive, being what are the percentage of similarly wanted people I need. In this case, each agent will be happy, if at least 30%, at least 30% of his neighbors are of his own kind. So he's not racist. He's just very liberal. All he wants is just 30% of his own kind. And since we started with a random configuration, as you can see, on an average for the entire system, the average for this is for the macro behavior. At a macro level, for the entire system, as we can see, if we can observe it, because this is a randomly generated world, we see roughly 50% similarity. What that means, like each agent has half of his neighbors of his own kind, and the remaining half are of a different kind. So that we started with the ideal configuration, the starting initial configuration, and now we will proceed with the simulation, where in each step the agent will evaluate his micro motives, which is the percentage of similar people he wants, and we'll see how the percentage at a global level, at a macro level, for the entire system, we'll see how the percentage similar for the entire system, how that evolves over time, and you can see how many people are happy. The percentage people are happy if 30, in this case 30% or above of his neighbors are of his own kind, otherwise he'll be unhappy. So people want to be happy, so they keep moving around. And let's see how this simulation continues. See, in this case, I'm going to reset this again. So once again, we started with a equal distribution of neighbors. The percentage similar at a global level is 50%. At a micro level, these people want their neighbors to be at least 30% or above. 30% or above of their neighbors are similar to them, and we start the simulation. Here we say go. Wow, this simulation quickly came to a stable configuration. It has reached equilibrium. So what do we observe? In this world, look, see, don't you see segregation in this region? You see, in this region they're all red guys. This is all pockets of green people. You see a segregated region. And you see, the interesting thing is, the people are fairly liberal people, in the sense that all they want is just at least 30% of their at least just 30% of their neighbors have to be like them. But because of the individual preference of each agent in this manner, the macro behavior is we end up in a world where people are living with people are living with a world where 70% of the neighbors are of the same kind, in the sense that even though the micro motives are liberal, the people are not necessarily racist. They're ending up in a configuration where they are kind of segregated. Isn't this beautiful? There is no correlation between micro motives and macro behavior. Let's make the people even more liberal, in the sense that all they care about is just 20% of their own kind. If at least 20% of the neighbors are of their own kind, each agent will stay in that place, otherwise he'll just move away. So let's simulate this and see what happens. Let's reset this thing, in a world where 50-50 probability of your neighbor being of the same kind or a different kind, and we'll start with this. Go. Wow, once again you see this has somewhat kind of stabilized, but you see, even though we want 20% of the individual percentage similarity wanted is 20%, the global at a macro level, we are getting a percentage similarity of 60%. This is fantastic. And let's change this number, I'll change this number to say, now people want at least say 45% of the, and this is like, people are liberal, people are happy if the percentage similar to them is 45%. Let's set this up world, and let's see how this world evolves. Wow, look at this, look at this, look at the racial segregation you have found. This is similar to what we have seen in Chicago, LA, and New York City, and a bunch of other cities. So what does this show? Even though people are not necessarily racist, in the sense that the percentage similarity wanted is just 45%, at least 45% similarity is enough for the individual agents, but because of the interaction that keep constantly moving around and looking for people, because of this the system emerges in such a way that you have 85% similarity on a whole. You see this region, this big clusters, green cluster, red cluster, green cluster, red cluster. This looks like a segregated city, but in reality each individual agent is just very liberal. Isn't this fantastic? With a simple paper and pencil model, we have shown that there is no relationship whatsoever between micro motives and macro behavior. There need not be a correlation between both of them. Isn't this fantastic? This is the beauty of creating some clean, simple, beautiful models. Of course, this model is false in the sense that this does not represent reality. It's incomplete. But it is useful in coming to a fantastic conclusion. Isn't this the beauty of science? And last but not the least, what we have discussed today is a much more broader topic called complex adaptive systems, and I'll talk more about this in the next slide. So once again, I would like to emphasize the main point. Macro behavior is not necessarily correlated with micro motives, and we showed that with a simple, beautiful model. And this guy, Thomas Schelling, he came up with this model. Man, this guy is a genius. No wonder he got a Nobel Prize in economics. Of course, he got it for his work in game theory. But see the power of modeling. And as we have said before, all models are wrong, but some are more useful, and this is a really useful model. Hats off to this guy. And as I said, this topic is related to complex adaptive systems, and I'll just briefly touch upon complex adaptive systems before we end this video. Complex adaptive systems, as the name implies, it does not consist of complicated things. Say the jet engine is a complicated system, but it is not a complex system, because I'll tell you the characteristics of a complex adaptive system. You have a large number of simple interacting elements. In this case, the red and green guys in our model, simple people, a large number of them. We took a large number of them with simple elements with simple micro motives and with simple rules, and people interact in a non-linear fashion. You just can't write simple equations and say what the next state is going to be. And because of the non-linear interactions, based on the variation in the parameters, say if people want 30% similarity, we got with certain kind of a world. If people want 50% similarity, we got certain kind of a world. You change the interaction, you change things, and you see a non-linear change, and suddenly patterns will emerge in this complex adaptive system, in the sense that it is complex and individual agents adapt to this, constantly adapt to their environment, and you come up with fantastic patterns, and sometimes randomness, and sometimes the system will never settle in equilibrium. And this complex adaptive systems, you'll come across this thing in many fields: mathematics, biology, art, society. And today we chose a topic from society, and next time I'll choose a different topic. But this is a really fantastic and rich field, and I can just go on making thousands of videos on just complex adaptive systems itself. But you got the main point. So in summary, micro motives and macro behavior are not necessarily correlated. B, models can be false, they can be incomplete, but some of them can be very, very useful. And the beauty of science is coming up with a simple but elegant model that explains what you want to do. that proves or disproves your hypothesis, and that is science. So we started with a topic related to society, but we are now ending with on a scientific note. And I hope you really enjoyed this video. Thank you for watching. Have a good weekend. Signing off. And next week I'll come up with another nice scientific video. Thank you. Bye.